Hello and welcome to this episode of Microchips. In this episode we'll be looking at the Harvard 410T CB radio that I bought off eBay and seeing what we can do with the mess that it seems to be in. There's a few things that need addressing, like this severely corroded battery compartment, the charging port. But first let's make it a little bit more simple to work on. So we'll disconnect the battery compartment completely, put that to one side for later. Then we'll disconnect the antenna, which is broken, and may be able to do something with that with a replacement antenna. But as you can see, this is well corroded. But we'll leave that till later on, as we need to address the other problems this radio has. So we'll pop the microphone out of the front panel. Disconnect the front panel LEDs, or unscrew them. We'll desolder the speaker connections, as we don't need those just yet. All these things we can put back on later once it's had a good clean. So we'll put the front panel to one side and put the circuit board in a circuit board holder. We'll disconnect the remaining side of the S meter that was connected. From the first video we found that the wire connecting to the other side of the S meter was corroded and had fallen off the board, and this is what I really wanted to get rid of and address later on, was this charging port with all the so I'll test if the charging port works later on. Maybe I'll replace it with a barrel connector instead. But we need to find out what all these wires do. So looking at the schematic, there's a capacitor, a diode, and that goes off to the power switch. Well, the capacitor is located on the back of the charging socket. And there's the white wire that comes from the charging socket. And there we have on the board, we have our reverse polarity diode. So we are safe to remove the whole charging port from the radio. We can reconnect this back up later on if needed. So we'll just desolder all these wires, because all this is just a diode on the board and that's it, so no need to worry about anything else. And we can remove the charge socket completely from the radio and tidy it up later. And there we have it, gone. I don't know what sort of modification this was, but it looks awful, and I don't think it was doing the radio any good whatsoever. I'll just desolder the remaining wires, which is just a ground contact, or a negative contact, should we say. That can go away. Now this should make it a lot easier to work on. And there's our connection for our signal meter. Which, funnily enough, is just another negative ground connection. So instead of using this corroded piece of wire, we'll just cut ourselves a nice new piece of wire. And we'll get the signal meter working, because it will help us whilst we're diagnosing this radio. A little twist of the connectors. And we'll just tin the wires. So let's remove the old corroded piece of wire. Nice new solder on it. And connect it to the signal meter. Now the next job is remove the remains of the old wire from the circuit board. A little bit of fresh solder first. Try and wick off as much as we can, and there's the remains of the old cable. Push that through. And take it away from the radio. Another quick tidy up with the solder wick. Bend the wire so it doesn't drop out. And solder it in place. Now let's solder the other wire back to the signal meter. So quick tinning. new solder on both of the connections. And solder it into place. So hopefully that should restore functionality of our signal meter. So we'll connect my power supply to the switch. And to the negative contact. And let's have a look at the signal meter. Now on the signal meter it does actually say RF power on the bottom scale, but looking at the schematic this is just a battery level. See, it says RF power, well that is actually a lie, that is just battery level, because it still shows the same with no RF output transistor in place. And speaking of RF output transistors, we're now going to remove this from the board and test it. Because I think something is very strange happening around this circuit. Let's try and measure it in circuit first. But I don't think this is going to be possible due to a coil that is actually across two of the terminals. So the only way to read this properly is to remove it from circuit. Because remember, something that is short at DC level may not be short at radio frequency level. So again, fresh solder. And some fresh desolder braid. And let's get this out of the radio and tested. I think the solder in this radio was pre-lead free solder, so everything flows quite nicely. Now, as always with a power output transistor, it's connected to a heatsink of some sort, and the collector of the transistor must be isolated from the heatsink, or at least isolated from ground, which normally the heatsink is connected to. So that is why there is a plastic ring and there's a mica washer. So we'll carefully remove those. Carefully remove a couple of components out of the way to get us access to it. And we'll put that away in a safe place. Gently move the mica washer or the mica insulator out of the way. And let's remove it from the radio. There's a quick diagram of the output, and as you can see, there is coils that could show short at continuity test. So there's our transistor. Now let's try and measure this transistor by using the multimeter. So that was the collector. So this transistor should be an NPN, so as soon as we find the base we should be good. Just not making a good contact there. So let's try a component tester. And the component tester says it's still a transistor and working okay, maybe. It doesn't show that it's open circuit or short circuit, so it's a good start. So going off the base was the center one. And yes, it measures correctly. Now, whilst I was messing about with this radio, I noticed it had a very strange fault, and there seems to be a resistor that's been cut. Maybe that's been done from the factory, I don't know. But you can see from my oscilloscope that when you flex the board, the RF signal jumps up and down, and you can actually hear this reflected on another radio. So this needs to be looked at. But in the meantime, I think the actual PA transistor failed on me. But anyway, we're going to leave this for this episode, and we'll carry on in part 2. So, see you in the next video.